In March 2025, something entered our solar system that shouldn't exist. It wasn't a spacecraft, not an asteroid, not anything we've seen before. It came screaming in from the darkness between stars, silent, cold, and ancient. Astronomers named it 3I Atlas, but what they discovered next made even seasoned scientists uneasy. Its speed was impossible, its path unnatural, and its chemistry unlike anything found in our own solar system. Some said it was just another comet. Others whispered it might be something far stranger, a messenger from beyond, or even a fragment of technology left adrift between worlds. For a few brief months, humanity had the chance to study it, before it disappeared forever into the void. But here's what the news didn't tell you. 3I Atlas wasn't just passing by. It was trying to tell us something. It was discovered on July 1st, 2025, by the Atlas Survey Telescope in Chile. Early observations identified its trajectory as hyperbolic, that is, not bound to our sun. That means it came from outside our solar system. It's only the third object of its kind we've ever seen, after Oumuamua in 2017 and 2I Borisov in 2019. And that's just the start. At the time of observation, 3I Atlas showed signs of activity even while still far from the sun. Scientists began to monitor it across telescopes worldwide to catch clues of its composition and behavior. The significance is massive. Every time we observe an interstellar visitor, we get a sample of material from another star system, something completely alien to our own solar neighborhood. It offers a rare window into chemical processes, planet formation, and cosmic evolution beyond Earth's boundary. What makes 3I Atlas even more intriguing is its unusual composition. Spectroscopy reveals it is rich in carbon dioxide, CO2, with a CO2 to water ratio among the highest ever seen in comets. Water, carbon monoxide, nickel, cyanide, and other elements have also been detected. One particularly odd feature: an anti-tail. Instead of tail material streaming away from the sun, part of its glow extends toward the sun, a reverse direction. That's extremely rare and not fully understood. Some propose dust dynamics or sublimation geometry might explain it. Then there's the color shift. Recent observations suggest parts of 3I Atlas might be turning green, something comets sometimes do when gases like cyanide are present. Its activity also seems to begin far from the sun, in regions where we'd expect comets to be inactive. That challenges our models of how comets outgas. These anomalies have led to speculation. Could it be more than a comet? But most researchers caution that natural processes remain the likely explanation. Still, the oddities demand deeper attention. Because of its strange behaviors, some scientists have speculated it might not be a simple comet. Avi Loeb, a high-profile astrophysicist, has suggested the possibility of engineered origin or alien spacecraft, citing its anomalies. Such ideas attract sensational headlines, but the majority of the astronomical community treats 3I Atlas as a natural comet. Critics argue the spacecraft hypothesis distracts from the hard science and that all observed characteristics align with unusual but natural cometary behavior. For example, detection of gases like carbon dioxide, water vapor, nickel, and cyanide, all common in comets, provide strong evidence for natural origin. Still, the mystery remains. When a comet doesn't act like a comet, how do we distinguish between rare natural processes and something more exotic? That tension fuels public fascination and scientific investigation alike. It isn't just a comet passing by, it's a messenger. It traveled for millions, maybe billions, of years through the silent void between stars. Its trajectory tells us it didn't originate anywhere near our sun. It came from another system entirely. Unlike comets bound to the solar system, 3I Atlas will never return once it leaves. It's a one-time encounter. Every atom of dust it sheds carries information about a place humanity may never visit, a snapshot of another solar system's chemistry. Telescopes like Hubble and the James Webb Space Telescope observed it closely, revealing patterns in its coma and tail that defy standard models. Scientists are still studying how radiation pressure and solar heating shaped its bizarre anti-tail. Each new dataset challenges what we thought we knew about comets, and by extension, about how planetary systems form throughout the galaxy. Mainstream coverage celebrated 3I Atlas as an astronomical curiosity, but few outlets explained why it matters. They didn't tell you that every interstellar object is a cosmic time capsule. Its chemical makeup holds the story of the system that birthed it. Different temperatures, different elemental ratios, different starlight. They didn't tell you that analyzing the chemistry of 3I Atlas could rewrite everything we know about life's beginnings. Inside this strange visitor were molecules like hydrogen cyanide and methanol, chemicals that don't just exist by chance. They are precursors to amino acids, the basic units that form proteins, and ultimately, life itself. When scientists detected these compounds through infrared spectroscopy, it raised an astonishing question. Could the seeds of life be everywhere in the universe? Because if molecules like these are forming in the icy shells of objects drifting between stars, it means nature doesn't need Earth to make life's ingredients. It's doing it all the time, in the silent dark of interstellar space. That idea changes everything. It means that life might not be a miracle limited to one small blue world. It might be the rule of the cosmos, a pattern written into the chemistry of creation itself. And yet, the headlines barely mentioned it. They showed pretty pictures of a greenish comet, but they missed the deeper meaning. It isn't just a chunk of ice and dust. It's a time capsule carrying the signature of another star system, a glimpse into a different version of cosmic evolution. As 3I Atlas continues its escape trajectory out of our solar system, telescopes across the planet are locked on it, gathering every photon they can before it fades forever. Teams at NASA, the European Space Agency, and observatories in Chile, Hawaii, and Spain are building complex models of how sunlight, radiation pressure, and solar wind interact with its fragile nucleus. Early data suggests something remarkable. The nucleus of 3I Atlas might be smaller and weaker than expected, possibly less than a kilometer across, and made of loosely bound dust and volatile ice. This fragility could explain why it suddenly brightens. Those flare-ups we see could be the comet breaking apart in real time. And then there's the anti-tail, the bizarre stream of material pointing toward the sun instead of away. Normally, radiation pressure pushes dust backward, forming a classic tail. But in 3I Atlas, part of the dust seems to move in the opposite direction. Some scientists believe it's caused by the unique angle of its orbit and the way sunlight reflects off its fine dust grains. Others suspect there's still an unknown force at play. Every observation matters. Each fragment that breaks off becomes a sample of pure interstellar material, an unedited chemical record from a place we'll never visit. Even after 3I Atlas is gone, that data will remain, acting as a kind of cosmic autopsy, revealing how other solar systems might form, evolve, and even produce the building blocks of life. Astronomers see 3I Atlas not just as a discovery, but as a preview of what's coming. Statistically, there could be thousands of interstellar objects passing through our solar system every year, most of them too faint to detect. But that's about to change. The upcoming Vera C. Rubin Observatory in Chile will begin full operations soon. Its ultra-sensitive survey camera will scan the entire southern sky every few nights, catching even the faintest interstellar travelers. For the first time in history, humanity will be able to routinely study visitors from other star systems, not once in a lifetime, but possibly every month. What makes 3I Atlas so profound isn't its tail or composition, its perspective. Every interstellar object is a reminder that the universe is not static. Systems trade debris, material, and maybe even life. Comets like this could be couriers of organic molecules, seeding young planets across the Milky Way. That possibility connects us all to a shared galactic origin. It shows us that our solar system isn't isolated. It's part of a vast network of cosmic exchange. The dust on your skin and the elements in your blood were forged in other stars, perhaps once part of comets just like this. When we look at 3I Atlas, we're not just seeing a rock from afar, we're witnessing our own story returning home. While the news treated 3I Atlas as a curiosity, the truth is deeper. It's a symbol of connection, a bridge between stars. It tells us that the universe is alive with movement, exchange, and memory. For a brief moment, humanity glimpsed a visitor from beyond and tried to decode its secrets. The next time the headlines show a faint comet in the sky, remember, it might not be from here. It could carry the chemistry of another sun, the history of another world, and perhaps the clues to our own beginnings.